Okay, hi everyone. So my name is Jay Werber. I am an assistant professor at the University of Toronto. This video is a demonstration of how to make a scatter plot in Origin. Particularly, we're going to try to recreate a figure that I had in this paper from 2022. So this figure, figure 4 here. So first, let me just introduce you to the paper. So this is a paper in ES&T, Environmental Science and Technology. It was the last paper of my postdoc in the lab of Professor Mark Hillmeyer at the University of Minnesota. And in this paper, we created these microcapsules, these polymer microcapsules that had a copper selective ligand in the walls. These copper selective ligands would bind copper, bring them in, and then exchange the copper for protons that were inside of these acid droplets inside of the microcapsule. And so this is what we called a mimic, a solid mimic of an emulsion liquid membrane, which is another technology. So the premise here is that you're trying to take up as much copper as you can and take it up as selectively as you can. You want to, the example separation that we did was copper separating from nickel. And so that's a common separation that's needed in hydrometallurgy. And so that's sort of shown schematically here. And in this figure 4, it sort of shows how these capsules work, where um, the copper selective ligand would bring copper into the inner droplets. And what we did is we varied the amount of ligand in the walls. So that's the LIX84I content in subplot A. And so you can see that as we go from 0 up to 1 weight percent of the ligand in the walls, we get faster and faster uptake of copper. So the y-axis here is the copper concentration in the aqueous solution around the microcapsules. So you can see that the kinetics get faster, but the amount of copper that's taken up doesn't change too much. But on the bottom, you can see that as you increase the acid concentration from 20 millimolar to 500 millimolar sulfuric acid, you get the same kinetics because we have the same amount of ligand in the walls, and you get more and more copper uptake because you have more protons on the inside that can exchange for those copper ions. So every copper that gets taken up gets replaced by 2 protons going the other way. All right, and so that is this figure in a nutshell. And I just want to sort of highlight some of the design concepts in this figure because this is how I like to make figures. Obviously, everyone has their own unique desires when it comes to what they think makes a good figure. But some of the design concepts that are going into this one, I'm just going to sort of walk through. So first off, you want to make sure that all the text is legible. So I just zoomed in, but really you want the text to be legible when it's zoomed out, something like this, when the page is the normal size that somebody would read when they're printing it out. So that's really important. Having basically as much information in the figure as possible, but still being really legible. You want the reader to be able to get information from the figure without having to go back and forth between the figure and the figure caption, and certainly not between the figure and the text, right? That's not really what you want. Other things is you want to make sure that the readers can sort of tell which data series is which. If they print it in grayscale, you want to make sure that they can still see the figure in grayscale. I'm not sure if you can see this, but I'm going to make my screen go gray. And you can see, so for me, it's gray, but you can still distinguish the different data series because each data series uses a different shape for the symbol. So it's still legible. Other than that, I have a model here that I am showing that is the solid lines. And so this is a model that I did in Python to try and model what the transport should be. And for each data series, the model color matches the data series. But in the legend, I only have one line, which is a black line. And that's just to keep the legend as concise as possible because you don't want the legend to be overwhelming. So those are some of the design features that went into um, the, um, the figure. And so now we're going to recreate it in Origin. All right, so I am not an expert in Origin. I'm not affiliated with Origin in any way. And I'm certainly not the perfect person to do this, but this is how I sort of make a figure in origin. So first off, here's our data. So this is data from that manuscript. So this is the data for the scatter plot, and then these are the data for the model that fits the scatter plot. So I'm going to copy it in. So what I found in origin is it gets a little wonky if you try to do the headings and the data at the same time. So I'm going to do them separately. All right. So long name. I'm going to do time minutes here. And so there's the data series. And now I'm going to copy in the model. So the model, I'm going to just scroll all the way down. So I'm just getting it from Excel into Origin at the moment. And going back up and doing the same thing with these labels. All right, so now we have everything in Origin, but we need to make sure that Origin knows what is what. So as you can see, these columns are the means. So these are the data points. And then these are the standard deviations. And so I need to tell Origin which is data and which is a standard deviation. And so you can see what they are based on this, what's in parentheses here. So this is the x-axis. You can see the A is the x-axis. And then B, C, all the rest of them are currently y-axes. So I'm going to take each of these that are the standard deviations and then turn them into y errors, which is the standard deviations in the y-axis. So you can do it for the x-axis as well. And the way this works is that the y errors are linked with the y data set that is just before it, right? So the y data set that precedes it. All right, so now you can see that each of those one says y error plus or minus, and so on. All right, the other thing we need to do is link these guys with this with this other x-axis, right? So this is a different x series. So I'm going to change this to x. And now you can see that it called this x2. And then everything after that is y2. And everything before it is y1. And this tells you which sort of x series each y data series is linked to, right? Okay, so that's pretty much all we needed to do in terms of linking the data. And now we can make our plot. And so I'm going to just select all of these y and y error bars, and then go to plot, and then go to scatter plot. Okay, and it's going to boom, make a data series, make a plot for me. So this is the default for Origin. Doesn't look terrible, but it doesn't really look very good. Again, I kind of want it to look like this. I want it to look like this on the right, right? So this is the format that I kind of like, where the symbols are black on the outlines and then colored on the inside, okay? In contrast, these guys are just solid symbols with no outline. And they're also pretty small, right? So if I was going to zoom out, it just is not quite publication quality, right? This is not a beautiful figure. So let's try to make this look a little nicer. So the first thing I'm going to do is try and make this the right size. And so I'm going to just show you one really weird thing with Origin that people get confused about, which is what's called the fixed factor. But if I take this guy and then I shrink it, not like that. If I shrink the whole thing, you can see the text gets smaller. Everything gets smaller. So basically, Origin scales everything based on the size of the figure. And that is what they call scale elements here. And I don't want that. I want it to stay the same size. So I'm going to say fixed factor. And then now when I do it, if I change the size, let's say like that, you can see that all the text stays the same size, the symbols stay the same size, but now the whole layer gets smaller without shrinking everything. So great, so I did that. I'm going to delete this legend just for now. And now it's starting to look better, just everything sort of a more proper size. And yeah, so now it looks not too bad, right? So I could change, why don't we change the data series? Actually, let's do this first. So I'm going to, I change it to independent instead of dependent. I'm just going to do each thing individually. So I'm going to make this a little smaller. and then edit it on the side so you can sort of see how it goes. All right, so I'm going to make these a little bigger, the symbols. I'm going to change to the open square, but then I'm going to make it black on the outside, and I'm going to fill it with a color. Okay. So I'm going to click apply, and you can see that now that top one is like this. I'm going to change the edge thickness. I'm just going to change this to 15. Give that a shot, and it's about the same. Maybe 18. I'll do 18, so it's a little thicker. Great. So let's do that for every single one of these symbols. I'm going to make them size 12, black on the outside. And then color-wise, I like to use sort of the pastel colors. This Q13 color 4 line is what I tend to use. That, again, is sort of personal preference. Ooh, I just realized I added too much data. So some of this data I don't want to be in here, actually. So I'm going to ungroup this, and I'm going to remove these two. And they were linked to these. So I'm going to do that. All right, so now the data series is gone. You can see the y-axis changed. It was weird. So basically what happened here is rather than doing 0.1 for the major ticks, like it was initially, it changed to 0.05. So let's do it back to 0.1. And to make it so it doesn't change again on me, I'm going to change this rescale to fixed instead of what it was before. All right, so that is that. Let's do these data series one by one. Next one. And then the last one here. I think I forgot to change the edge thickness. Let's do that. All right, so great. So now it looks better, certainly looks better. And I'm going to change the standard deviations, those error bars, what they look like. So the cap width looks fine. So the cap width is how wide those tops and bottoms are. So if I change this to 24, for example, you can see that that's changed. So I liked it at 8. But the line width I didn't think was thick enough. So I'm going to change these all to 1.5. Although perhaps that is a little overwhelming. We will reassess. Oops. So yeah, that's a little overwhelming. So why don't we change these to 1 maybe? Yeah, that looks better. All right, so now we have our data series, the data plots, not the model, but just the actual data, and it looks pretty good. So this is kind of how I would like it to look. You can see that the y-axis and the tick labels are, their normal size, which was, I think, 18 and 22. So 18 for the tick labels, 22 for the axis title. And now it's sort of what I would consider a proper size for a figure that would be smaller. So actually, if I zoomed out, so this would be sort of the size you would want, and it's a little small. So I'm going to make these maybe 26, make this 22, 22, 26. And the other thing I can do instead of changing the font sizes is I can just sort of shrink this, right? So that will make the things bigger, but it'll make everything bigger. The symbol size bigger, the line width's bigger, and everything. All right, so the y-axis here we had as being Cu2 plus millimolar. So I'm just going to do this directly in, and then I want this to be superscript, so I'm going to just change it to superscript at the top. Great, so that's the y-axis, and the x-axis looks fine already. And now we need the model. Okay, so let's add the models in. So I'm going to go layer contents, and then go down here. Here are the model data. So I have the titles for each of those columns in the workbook. And that lets me know what is what. And these guys I want to be, rather than scatter, I want them to be a line. So I'll apply, and you can see, great. So these lines are now on the plot. The issue though is they're over the data, and I don't want them to be over the data. So I'm going to make these go first, so that they're behind the data. All right, so now we can see that the lines are behind the data. And what we want to do now is basically, I'm going to make these independent, and then I'm going to make them 1.5 line width and change the color so that they match the actual symbols. All right, so let's do that for each of these. Awesome. And that is the figure. The only thing that's missing is the legend. So let's add the legend. So I'm going to, so first of all, actually, one thing that's kind of weird is because I've shrunk the image, we still have all this white space, and that's fine. I'm just gonna, so at the end of after we're done making the figure, I'll sort of shrink it to match the actual size of our plot. One thing to note here, the way that this image is now, let's see, actually, what was the x-axis? I did major ticks of 30 minutes. I think that would be a little better. This looks a little crammed. So let's make this 30 minutes. Why? I'm gonna do fixed so it doesn't change on me. And yeah, so now we have this, looks pretty good. This is totally fine to have ticks going out and just an x-axis and a y-axis. The other format that I like to use is where the ticks go in and it's on all four sides. That is sort of personal preference. Both of them look fine. Both of them are perfectly acceptable. But I'm going to change it just to sort of show how to do it. So you can go to line and ticks, and you can change the thickness of the ticks. So if I change this to 4, for example, now you can see the x-axis is much thicker. Not necessary in this case. But I will make them go in. So major ticks in, minor ticks in, apply. And then I'm going to do same for the bottom and the top. All right. And then I will do the same thing for the left. And you can see that it popped in. And I'm going to do same for the right. All right. So now we have a figure that looks very similar to the one in the text. Although the colors and the symbols are a little different, but that doesn't really matter. So the last thing we need is the legend. So I'm going to do, I deleted the legend earlier. So now to get the legend back, we're going to graph, reconstruct legend. And now we have this whole big thing. And this is kind of what I was talking about. If we had a legend that was this big, let's say, we change this to, 16 font or something like that, maybe 18, or maybe 20. Let's do 20. This is overwhelming, right? This is way too much. So we don't really want that. We want just the symbols and a black line for the model. The issue is the black line for the model is sort of hard to do, right? So we need to actually have a dummy data series in there. So I'm going to do that by just having this be what I call dummy. I'm going to go back and I'm going to add this to this guy. So now dummy's down here. I'm going to make dummy a line, not a scatter. Apply. So now I have this dummy one. And now I can change this dummy, which doesn't have any data, so it doesn't actually show up on the plot, to being the same line width as our models, but black, right? So it's just sort of generic. All right. And so now we have essentially the outlines of our legend, except we are going to delete what we don't want, which is this 1 through 4. We don't want those. All right. And then, so if I hit apply, you can see that now we're sort of more what it was before in the manuscripts. And so I'm going to do what it was in the paper, which was Lix 84I content. and I'll make that bold. And then I'm going to change this to 0 weight percent, 0.1 weight percent, 0.5 weight percent, and 1 weight percent. And I'm going to change this one to mod. And so origin sort of shows you at the bottom what it's going to look like. But you could also hit apply and see it over here, right? So now we have our legend, essentially. And the only other thing that I don't really like is I don't really like having a frame around my legends. That's, again, personal preference, but this is what I think tends to look best. And so I'm going to go to frame, select none, apply. Now it's gone. And now we essentially have our first figure. The last thing, if we go back to the manuscript, is had a little text box in the corner. So I'm going to add that. So I'll do text box, 200 milligrams, inner solution was 0.5 molar H2SO4. Okay, so I'm going to make these subscripts. Always got to pay attention to detail. And looking at the font size, this is 20, this is 22. Let's make those the same. So I'm going to make that 20. And now we have our first figure. So fabulous. So if we go back here, you can see that the two figures are linked. They actually share the same x-axis. And just to make it look nice, I made them have the exact same size. So the easiest way to do this is to just copy the same figure, right? They have the same formatting. So I'm just going to copy that figure again, and then try to make it just go directly below the other one. So I'm just going to do Control-C, Control-V, and now it's down here. Okay, so now we have another figure. I'm going to fit the page to the layers to make everything be part of the white content. So now we have this, the page now fits our layers a little better. And again, I want these two to be directly on top of each other. So I'm going to move this up a little bit so that it's sort of the right height. The other thing in the paper, by the way, that I did is I actually deleted these and had this be sort of like this, because they share the same x-axis, and this just saves space. That, again, is a personal preference thing. Either way is totally fine. But if you leave it like this, you're using extra space for the x-axis. But that might make it a little clearer in terms of being able to read the data. So there's no either path is not perfect, and either path has pros and cons. But the one thing we do want to do is make this look nice and have them be aligned. So I'm going to go to double click on that. I'm going to go to size, and you can see that it's 17.21 units from the left, percentages of the page from the left. So I'm going to go do the same thing on the bottom one and just make sure that those are the same, and they're not. So this one's 17.73. It's a little further to the right than the other one. So I'm going to do this, and they're both 17.21. Okay. All right. So now we have our second data set, second plot, I mean. And now the main thing to do is to have the right data. So I don't want some of the data in it, but I do want this bottom one. So if you look at the original plot, the purple circles are the same data series in the top and the bottom. And so that was intentional. I'm using the same color scheme in both plots so that the reader knows that it's the same data set. Okay, so I am going to do the same thing here and keep that data series the same color. But I want to get rid of all the other stuff that we don't want. So I'm going to get rid of this one, this one, this one, this one, this one, this one, and then the three error bars. So those are gone. If I hit apply, so you can see that it's just the one data series now. So let's add in the other stuff that we want. So I'm going to add this guy in and this guy in. So these are our other data. I do want this first, though. Not that it matters too much, but I do want that first. Okay, and then for the model, we need the model in there too. So let's add in the models. and these should be lines again. All right, so if we hit apply, boom. So now we have things in there. It's the right data, just doesn't look right yet. So let's fix it. Oh, the other thing we want to do again is just as like before, we want this to be at the front. So that it's behind the data. All right, and so let's fix these symbols and stuff. So we're going to go next in line. So next in line is the diamond shape, I guess. Gonna do the same thing. So black on the outside. Fill it with, I guess the next in line is purple. Apply. Next one, we're going to do this left facing triangle. I don't really like this brown. I don't really like this so much, so I'm going to change it to this teal. Oh, I forgot to do the edge thicknesses. And I forgot to do the size of the symbol. Oh, no, I did. Okay, perfect. So edge thickness, let's make this 18 just to match the other things. Great. And then lastly, we got to make the lines match. So, oh, let's make, yeah, these guys, cap width should be 1, right? Just like the other ones. Okay, and then I'm going to make these lines be the proper width, which is 1.5, and be the proper color. Again, just matching the lines with the symbol color. All right, and we're almost there. So I'm going to just change the legend to match the data. So this was, what was it? The internal H2SO4 concentration. So inside the capsules. All right, so I'm gonna delete all this. Make this subscripts. You gotta make them subscripts. No reason not to. And I'm gonna make this all bold. All right, so that's that. And now I gotta make these things match. So it looks like this is now our model. Oops, not 6. So the dummy one is now data series 6. I sort of lost track of that a little bit. The 1 weight percent, sorry, let's see, there are only 3 of them. Yes. This one should be 20 millimolar. The next one should be 100 millimolar. And I know this only because this is my paper. And now we got to make sure the actual data series actually apply to the right data. And so this is actually wrong. So let's make this 7, this 8, and then this should be 9, 4, 4. 4 is it. Great. All right. That's it. So that is the new legend. I'm going to now change this guy to be the Lix84i account, and which was 1 weight percent. And the reason I'm including this text box is so that, oh, and the weird thing about Origin, you can't like sort of make things go up and down without moving left and right with your mouse. So I just use the arrows to move things up and down so that they don't move left and right. So the reason I'm adding this text is just to give key information so that the reader can know the key information in the experiment without having to go to the caption to see it. All right, and then the very last thing is including the A and the B, just the headings for the subplots. I'm basically going to just make this kind of big, maybe 42. How about that? Looks all right. And I'm going to make a copy of that. I'm going to zoom in, make them overlap. There might be a better way than this. but now they overlap, right, in terms of their lateral dimension. And I am going to just hold the down button until this moves down all the way to here. And I'm going to change this to B. And now we have our figure. So I'm going to, the very, very last thing, change this, again, fit page to layers. I use a border width of 2. It's probably good enough. And now we have our figure. In terms of exporting from origin, the easiest thing to do is to send it out as an enhanced meta file, a Windows meta file. And the way that that works, so you do edit, copy graph as image, open dialog, and then you choose EMF, enhanced meta file. And the reason you do this rather than a PNG or a JPEG is that this is still vector-based, so it doesn't lose resolution. If you copy it into origin, which is sort of your main thing you would sorry, not origin, PowerPoint, which is the main thing you would sort of use for this, which is you make a figure in origin, you would pop it into PowerPoint, and if I zoom in, you can still see that it's perfect resolution, and these metafile files are really small, so it's pretty pretty good for that as well. And that's pretty much it. That is all you really need to know about making figures in Origin. So thank you very much.